Some technical difficulties during class with the recording, so this is another one just with an empty classroom, so I'm sorry. For those of you who are watching this for the first time and you don't get the questions that other students were asking, I'll try to cover everything that we talked about in class. This lesson will be fairly short. It's just talking about inverse matrices. What we're going to do is determine if matrices are inverses of each other and then find the inverse of a 2 by 2 matrix. So should be pretty simple. First thing we're going to talk about is the identity matrix. So it's a square matrix that has 1 for every element of the main diagonal and 0 in all other positions. It's called matrix I, so you denote it like this. The main diagonal is the one starting from right here. So when we're doing our determinant, how we go down like that, that's going to be our main diagonal. So that means the identity matrix looks like this. It's a square matrix. I could have a really big one. I could have a 3 by 3. Could look like this. So main diagonal again, and then zeros in all other spots. Just like when we do like 2 times 1, so if I have 2 times 1 that equals 2, this number just gives me this back. That's the same thing for an identity matrix. So if I have a matrix A that I'll just call A, B, C, D, the elements I'll just call A, B, C, D. If I multiply that by the identity matrix, then that will also equal the identity matrix times A, B, C, D. So notice how I can switch these and I still get the same thing. It's not always true, but it is in this case. If that continues out just like a 1, I get A, B, C, D back. So it works just like 1. I just get A, B, C, D back, so it's like 2 times 1, and then I'll just get A, B, C, D. That is the identity matrix. So the identity matrix is important because if we're going to determine if 2 matrices are inverses of each other, then their product has to be the identity matrix. So that just means that I will multiply these 2 together. So if I set this up just like normal matrix multiplication, 4, 5, 3, 4, 4, negative 5, negative 3, and 4. And then if I do my same little line things, just like this, of a new matrix. Here, multiplying those, and then adding them, I'll get 1, I'll get 0, I'll get 0, and then I'll get 1. So since this is the identity matrix, then hooray, these are inverses. You would just write yes. Notice you cannot switch these numbers. So you can't just switch these around. This is what your identity matrix looks like right here. If we go down to this one right here, and I set up multiplication again, 2, 3, 5, negative 1, 2, 3, negative 1, and negative 2. And then I draw this, then it'll be a 2 by 2. Go down like this, same multiplication. Then I'm going to get 2 times 4 minus 3, so I get 1, 0 up there. But notice here, if I do 2 times 5, that'll get 10. 1 times 1, I'll end up with 11. From right there, I know that this is not 0, so I would say no. One of the things to notice about these is in this first matrix right here, notice how this element and this element over here, that's the negative, so we're talking about the opposite. So opposites here. These are the same, but they don't always have to be. So just take that as an exception, not the rule. Alright, going on to the next part, finding the inverse of a matrix. First thing is find the determinant. Just like in a system of equations, a determinant determines whether or not you have a unique solution to your system of equations. In finding the inverse of a matrix, the determinant tells you whether or not you have an inverse. So there are some real-world functions that aren't invertible, that won't create a function when they are an inverse, or they're just not invertible in general. So, same thing for matrices. The definition for the inverse of a matrix, going back to this idea, is this, and I'll break that down in just a second. So this part right here, this is just talking about A inverse. So just like when you do F inverse, like if you do F inverse of X, same idea, just talking about an inverse. Notice that my determinant is my denominator, so that's why if I have 0, then I can't do the inverse. And then notice that I'm just taking elements of a matrix and putting them in these spots right there. So doing an example, if we look at this one right here, first, if I'm looking at this, I want to find the determinant. So this times this, so -1 times -7, minus 3 times 4 gets me -5. Since that is non-zero, then I'm going to go to this. So I do 1 over -5, and I have this matrix. What that means is I'm going to swap these numbers, so I'll get -7 and -1, and I'm going to do the opposite of these numbers. So -3 and -4. Notice that these ones stay in the same place. These ones swap. It might not always have all negatives. There might be some that are some positive. This is just a different one than some other ones. You can either leave your answer like this, or you can distribute that scalar, because we're just multiplying by scalar. So you could end up with 7/5. Oops, I did not make my matrix big enough. You could end up with 7/5, 3/5, 4/5, or 1/5. You could end up with a matrix that looks like that. Either one. And then if you wanted to double check, you would just multiply this matrix by this matrix, and then make sure you get the identity matrix. If we look at this last one right here, finding the determinant, 4 times 9 minus 6 times 6, that gets me 0. So this one, you just write no inverse, impossible, etc. So obviously, this is a little bit different than what we've been doing. On Friday, if you're in class, we'll be doing a cryptography activity where we use inverse matrices. So that's an application of that. Another application is also if I am solving a system of equations and I'm going to do something really simple. So let's say I have something that looks like this. And these are matrices. Problem is we can't divide matrices. Cannot divide matrices. So what we would have instead is something else. If I told you I have 10 apples and I want you to split them between 5 people, however, you can't divide numbers, so you can't divide 10 by 5. What you would have to do instead is do the inverse. So you would do the inverse of so you'd be doing multiplication, so you do the inverse of 2, which is 1/2, because that's 2 to the -1. Instead, you're just doing 1/2, so you would multiply 10 times 0.5. And then you could figure out how many you could split equally between 2 people or 5 people. You would do the inverse for this one. You would do the inverse of 5. So you do 5 to the -1. Sorry. Splitting between 2, so 5. 1 over 5, so 0.2 instead. And then that would tell you however many apples you could split. So in this case, we're not dividing, we're multiplying. We're using the inverse. Same idea here. Since we can't divide here, what we have to do is we have to use the inverse. So if you want to get rid of this A, if you multiply by A inverse on both sides, you'll get that, and you'll end up, these will cancel, because it's just like saying A over A, except for the fact that you can't say that because, sorry about that disconnection. except you can't say A over A just because you can't divide matrices. So that's just something else to think about. There are no problems on your homework that are like that, so don't worry about those, but it's just something interesting because you may get into that later on. I think basically that's all we talked about. So the homework will be on the calendar, and then there will be some other stuff on the calendar as well, so make sure you're looking at that and you're getting ready for the test next week. As always, let me know if you have any comments or questions. I try to be as available as I can, so let me know in class if you have any questions.